So for converting to radians, you're going to multiply by pi over 180. This first one's kind of nice because the zeros are going to cancel. So you get 33 pi over 18, and then those will both divide by 3. So 11 pi over 6. How did that one go? Good there. Okay. So same with this one. It's just this one's going to be a little bit more annoying. So pi over 180, the degree symbols cancel, but you are going to have to reduce that. It is negative, so don't forget to put the negative sign in front of it. You're going to divide them both by 5. So I would off to the side just divide 315 by 5. 5 times 6 is 30. And then 5 times 3 is 15. So on the numerator, 63 pi. Do you remember me saying you're going to do 180 divided by 5 a lot? Like for this reason, and you probably just do well to remember that one. Do you remember what that one is? It's 36. You can always work it off to the side like I did here, but you'd do well to know that one. And then same as we did in number 1, you're going to reduce that. Those will both divide by 9. So that is negative 7 pi over 4. Did you guys get through 3 and 4? Do you want me to just go and do 3 and 4? Okay, and then I'll pause it again and let you keep working. All right, so for these ones, it's backwards. You're going to multiply by 180 over pi so that the pi's cancel. So you almost can't mess it up. Like if you get it the wrong way, they're not going to cancel. Now, however you think best to get through this is fine. We all think differently. Here's what I do, though. I would not do 5 times 180 because that's going to give you a really big number. I would keep the 5 there and then do 180 divided by 12. Because if you divide, it's going to make the number smaller and you don't get a calculator. So you want to make the number smaller. So 12 times 1 is 12. 12 times 5 is 60. So it's times 15. And then it's not as hard to do 5 times 15, 75 degrees. This one, same thing. We're going to multiply by 180 over pi. Again, I would just keep the negative 7 there and do 180 divided by 6. That one I can actually do without writing anything off to the side because 18 divided by 6 is 3. It would just be 30. And then negative 7 times 30. Well, negative 7 times 3 is 21, like negative 21. So it'll be negative 210 degrees. All right, so for the reference angles, they are with the x-axis. So just make sure you always draw it to the x-axis. So what quadrant did you put 135 in? Second quadrant. And drawing it is, that's it. You get a point for that, right? Your reference angle is this part. So you could get that by doing 180 minus 135. So what do you get for that little bit in there? 45. Perfect. All right, negative 5, 6, you're going backwards. I still have my little toothpick here. So it's going to look like this. You start there and then you rotate backwards. If you go 6, 6, 1 whole pi backwards, that would put you here. But if you only went 5, 6, you just didn't quite make it. So it's going to look like that. And then this part is your reference angle, which would just be pi over 6. The nice thing about the radians is the denominator just matches. And we don't do negative reference angles. That's just a definition thing. So just by definition, they are not negative. All right, so the reference angles aren't too bad. The coterminal are a little tougher. All right, so 210. And if you're still working, that's fine. Just come back and check your answer once I get finished writing it. I'm just going to talk so it shows up on the video. All right, 210 would be in the third quadrant. So it would look like that. To get a positive and a negative coterminal angle, you just add or subtract a rotation. So what is the whole way around worth? Yeah, 360. So we're going to do 360 plus 210. And we're going to do 360 minus 210. Just for this one, make sure you slap a negative in front of it to show that you went backwards. All right. So this one would be 570. And this one would be negative 150. And that's the like, hey, you go this way, I'll go the other way. Like we'll meet on the other side. Did we just have like an adding problem? It happens. Right. Or did those go okay? All right. 3 pi over 4 is in the second quadrant. If you go 4/4, you went 1 whole pi, but we didn't go 4/4, we only went 3/4, so you didn't quite make it. What is the whole way around in radians? In degrees, it's 360, but what is the whole way in radians? It's 2 pi. So for fourths, good, that would be 8/4. So we're going to do the same thing. We're going to add for one of them, and then we're going to subtract for one of them. So the positive one would be 11 pi over 4. You're just adding one rotation. And then the negative one is -5 pi over 4. So again, that's like you go this way, I'll go the other way. We'll meet on the other side. All right, and then let's just go ahead and go over these last two. Or did that one go okay? Did anyone get those? Are we feeling all right? People in the back, are we all together here? Okay. Arc length is S equals R times theta. All right, let's all come back together here for these last two. These are just formulas that you memorize and plug in and get your answer, right? Arc length is like how far you went around, which I think is kind of cool. I mean, yeah, there's more formulas to memorize, but it's neat. You can find the length of a curved thing, which is just cool, all right? The only thing is your angle needs to be in radians. So we're going to multiply by pi over 180. And then to reduce that, we're going to divide by 5. So 5 times 2 is 10. 5 times 7 is 35. I just worked that off to the side. So your angle is 27 pi over what? Good. You're going to do that one a lot. Just remember that one, so you don't have to work that out every time. And then that's actually going to reduce to what, a little bit, divide by 9, right? So 3 pi over 4. All right, and then all you do is literally multiply them together. R is 4, theta is 3 pi over 4. So actually what happens to the 4s? Yeah, they cancel and you get 3 pi meters as your answer. If you're looking back at your notes, you're like, hey, Ms. Cole, you drew a picture. Yeah, I was trying to explain to you how it works and what it looks like. If you don't draw a picture on the quiz, that's fine. I'm not grading you on that. I was just trying to explain to you what we were doing. All right, now area, it's 1/2 r squared theta. Theta's already in radians, so you can just go plug everything in. 1/2, what is r? 8? 8 squared, and then times the angle. And so, yeah, we're going to just have to kind of sort our way through that. What is 8 squared? All right, that's 64. Half of 64 is 32. Can I make a suggestion? You write it as 32 over 1. That does end up helping people if you do that. And then the last thing you would do, unfortunately, you have to do 32 times 4. Just multiplying across here. 1 times 3 is just 3, so that's easy, but 32 times 4, what is that? 128 pi over 3. That doesn't reduce, so which is cool because then you just leave it. But what are your units for area? It says feet squared because it's 2-dimensional. So like, let me just draw you a picture because I think it's cool. Like, here's your circle. If you rotate to 4 pi over 3, that puts you in the 3rd quadrant. What we found is this area. Like, isn't that neat? Neat. I know you're like, we don't care. That's cool. You found the area of that amount. That's cool.